Hello guys, welcome back. Today we're gonna solve a medium problem. There's a number of subsequences that satisfy the given sum condition. Hmm. So the statement gives us a yes, then arrays of integers nums and an integers target. So we need to return the number of non-empty. Yeah, that means it must be at least one element. Uh, Non-empty subsequences of nums, yeah, suggest the sum of the minimum and the maximum element or it is not exceed target. Yeah, that means less than or equal to target. Mm. And we need to return the is it modulo, uh, yeah, 1 billion plus 7. Okay, that's the prime number. Um, all right. So remember the subsequences. That means you can select some element in the original array. Not is it it no, but it doesn't need to be continuously. Yeah, continuous. You can select some non-continuous element in the original array. So actually we don't need to focus or to care about the original order of these nums right here. So because we only need to care about the minimum and the maximum element, we don't need to choose the continuous sub array. So the order here is not important, and so all we need to focus on finding the minimum and the maximum element that is less than or equal to target. So for the first step, we're gonna sort this array in some order, maybe descending, maybe ascending, but in this case, I will choose ascending. For example, the first one, I would let's take the this example 3. It's short. Okay, it's already short. Okay, all right. So you can see the target here is like 50 points is the sum of means mark is much less than the target is the 12. Yeah. Mm. All right. You can see if there was if you choose the mean element. Let me choose change the color. All right. Purple. Okay. You choose a mean element and the mass element here. So it's gonna be 2 plus 6 is 8, right? And for if you choose this two element to the mean and the mass, so you can choose every element lying between these two. You can choose this or this because it doesn't affect the minimum and the maximum in these subsequences, right? But if you choose this 7, it might affect because the new maximum it changed was it changed. So the our problem turned into find only pair that the minimum plus the maximum is less than or equal to target. And then after you figure out that pair, for example I and J, you can select on on the element lying between these two. So we gonna got for each I and J pair, we got for example 0, 1, 2, 3, 4. This is 4, this is 0. So we got 3, right? That's it. J is minus I and minus 1 element between this and using a basic combinatorics knowledge here is we got the power h, which h is the number of element way. uh, Let me take example. The first one you select none, the second one you can select the first one, you can select the second one, and you select the third one, and like this, and 4, and the last one you select on 1, 2, 3, 4, 5, 6, 7. We missed one word. And the 3 3. All right. 1 2 3 4 5 6 7 8. 8, right? 2 power 3, 8. That is just the basic math knowledge. Okay. So first of all, I got a shot. Mm. Sorry. To sum up, we need to sort the initial array in maybe a standard orders, and we need to find on pair I and j. I in the on the left side is the minimum, and j in the right side is the maximum number, and keep that set. And you gonna form 2 power h. H is the number of element lying between these two exclusives, right? uh, but you may ask how to form these pair these pairs. Just use You can use for the position I, you got 2, right? And the target is line 13. Maybe sorry, I will guess that's the 8. For example, target is 8. So the maximum you can choose is 8 minus 2 is 6, right? So 2 plus 6 is 8. You can choose 7 because it's gonna become 9. It's 6. So you use binary search because the array is short, so you can binary search the 6 element here. Okay, you want to find it. So um, so you can choose on the this pair, right? And you can choose on the one between this as well as to the chase minus 1 to this as well to this. So mm, uh, let me see a more cosine formula. That's it from the A here. You can choose on the tray element. That's from the E plus 1 to the tray here, right? So there are, yeah, it's back to the problem. You choose tray H, and we minus the empty, the the non. Wait a minute. What happened if? Oh, all right. There's one more case that is, yeah. There's one more case that is, you need to, um, in the case the subarray only have one element, so that means it is equal to the max. Hmm, the max, right? So fix is choosing the mean, right? Fix it choosing the mean, and then you can select on here. This 4 element, you can choose whatever combinatorial combination of this. So you're gonna to 10 power h. H is the length of here, because let me demonstrate. 2, you can choose 2 only, or 2 with 3, 2 with 3, 2 with 4, or 2 with 6, right? You can choose, and you can choose 2 with 4 with 3 with 3, or 2 with 3 with 4. And that's mean all the combinatorial of the first element, that is the mean, with any element on the left side with the maximum boundary is j here. All right, I hope you understand it. All right, so gonna short first on. Let's short it. Short on. At the short, we're gonna use, as I said before, you can use binary search, but actually we can use 2 pointer to reduce the time complexity to the O1, ON. Because when the mean increase, the target is the target unchanged, right? So if mean increase, so the mass must be decreased. That means the tree must go down, go to the left side. So I'm gonna apply size num sine plus 1 4 to num sine. All right, y a j, and nums I plus num j is less than target, so we're gonna decrease j, right? If a is large j, so we're gonna break there, because we doesn't find any nums I and num j's that is match our condition. So now we got the trade and the, here's really last we're gonna write a function to calculate the power A and B. Remember the statics cause modulo 9 plus 7. If b equal to 1, I'm gonna return 1. TMP is power A divided by 2. This is used by the divide and conquer to calculate the power. No, if yeah is yeah, so gonna return A and return TMP. Alright. Answers gonna use long line here. Oh no. Answers the answer plus power of this must be trace minus r y. That's it. If this all right then. Right. Got it. First try and got a static. You can optimize this by using counting shot instead of shorting the array. So beyond the overall the overall time complexity will reduce to O(n), but there was something the power here still cost you to you still cost you log n to calculate. So the overall time complexity is n log n. How to optimize this? You can optimize this by trade off the space to calculate to and use counting shot to short this and you get the optimal solution. Let me check the first one. Oh, short range search. Oh, what's that? I think that's the counting shot maybe. Uh, uh, yeah, as I said before, you can use counting shot here and then use an array to calculate the power initially. Like that is pre-computing and just do line as I say, and if you got the 100% outstanding in the time, but that is okay. Understand the concept is more important. Have a nice day.